Assalamu alaikum. My name is Sundar Halil. Today I am here for the presentation of PC3 and my presentation topic is UV visible spectroscopy. Group number is 3 and I am here for presenting the part 2 which is based on characterizations and instrumentations. First of all, the characterization of visible spectroscopy. Ultraviolet visible spectroscopy based on the observation of the electronegative radiations which is UV visible region. Wavelength range of the ultraviolet spectroscopy is 200 to 400 nanometer and ultraviolet spectroscopy is 400 to 800 nanometer called visible spectroscopy. Radiation in these wavelengths is so relatively high energy and is sufficient to induce electronic transitions in molecules or atoms. UV spectroscopy is useful for investigating the electron structures, unsaturated molecules, and measuring the extent of their conjunctions. However, the usual available wavelength range of the measurement is 200 to 800 nanometer. Only a restricted number of transitions could be identified. This method had narrow range of uses in polymer science. Instrumentations. Optical system spectrometers are instruments that provide information about the intensity of light absorbed or transmitted as a function of wavelength. Both single and double beam optical systems are used in molecular absorption spectroscopy. Now, first of all, the diagram of single beam optical system. Double beam system is used extensively for spectroscopic studies. The individual component of system have some function as in single beam systems. Important difference in the radiation from source and split into two beams of experimentally equal intensity using a beam splitters. The, the intensity of the two beams after passing through the cells are then compared. Here are the diagram of double beam system. Radiation sources. Radiation sources, molecular absorptions must provide light over a continuum of wavelength. Traditionally, the two most common radiation sources used for UV spectroscopies were tungsten lamps or deuterium lamp. Here are the tungsten lamp. Tungsten lamp is similar in functioning to the ordinary electric light bulb. It contains a tungsten filament heated electricity to white light or generate a continuum spectrum. It has two shortcomings. The intensity of radiation at short wavelengths is too low. Furthermore, to maintain the constant intensity, electrical bump current to the bulb must be carefully controlled. Here are the tungsten lamp. Now, deuterium arc lamp. The deuterium lamp consists of deuterium gas in a quartz bulb through which there is an electrical discharge. The molecules are excited electrically and then excited molecule dissociated, emitting UV radiations. Here are the diagram. The next one is monochromators. Monochromators consist of the repulsion elements, entrance slits, exit slit plus increase mirror for collimating and focusing the beam of radiations. Two most common types of dispersion element, prism or gratings. Entrance slit allows light from the source to fall on the dispersion element. Dispersed light falls on the exit slit to the monochromators. The function of the slit is to permit only a very narrow band of light to pass through the sample and detectors. Detectors. The purpose to the detectors is convert the transmitted radiant energy into the equivalent amount of the electrical energy. Two types of the detectors are frequently used. Photomultiplier tube, the first one which includes the light strikes, coated cathodes emitting electrons. The electrons are attracted to a series of anodes known as dianodes, each having a successfully high positive voltage. These dianodes are of a material that gives off many scattered electrons when hit by a single electron. Initial electron emission at the cathodes triggers a multiple cascades of electrons with the PMT itself. Because of this amplifications, PMT are used in instruments designed to be extremely sensitive to very low light levels. The accumulations of electrons striking the anode produced a current signal that can be fed into a meter of recorder. The second one is photodiode arrays, which is used in the detectors, are new detectors which is used in modern spectrometers. Photodiodes are composed of silicon crystals that are sensitive to light in the wavelength range 170 to 1100 nanometers. Up on photon absorptions by the diode, a current is generated in the photodiode and this is proportional to the number of turns. Although photodiodes are not as sensitive as PMT because of the lack of Internal amplification. Their excellent linearity, speed, and small size make them useful in applications where light levels are adequate. PDA detectors are available in integrated circuits containing 256 to 2048 photodiodes in a linear arrangement. Each photodiode responds to a specific wavelength, and as a result, a complete UV visible spectrum can be obtained in less than 1 second. Thank you.